Hey everybody, welcome to Geometry, Section 8.6, the Law of Cosines. By the end of this lesson, you should be able to use the Law of Cosines to solve for a missing angle, use the Law of Cosines to solve for a missing side, and use the Law of Cosines along with the Law of Sines to solve for an entire triangle. So when we talk about the Law of Cosines, we're still dealing with that same triangle that when we did Law of Sines, where you've got three angles, and those three angles are represented by capital letters. And then you've got three sides, and those are represented by the lowercase letters. And the corresponding angles and sides are always directly across from each other. So angle A is directly across from side A. Angle B is directly across from side B. Angle C is directly across from side C. So if you were to look up Law of Cosines on your own, you'd probably give you three formulas. Okay? So those are the three formulas that we're going to work with. But if you notice, it's the exact same pattern for each formula. It's just the letters are kind of rotated around a little bit. So rather than do that, what we're going to do is we're going to focus on just one of those and focus on the pattern rather than the actual letters. Because sometimes they don't even give us the letters. They just say, here's the sides, here's the angle, go ahead and solve it. Okay? So don't get hung up on the letters as much as you do the pattern. So let's take a look at that pattern. So the very first part, c squared equals a squared plus b squared. That very much looks like Pythagorean theorem. Okay, so that's one way to remember the first part of it. But then the next part I want you to notice is that there's cosine of c at the very end. Okay, it'll always be cosine because it's law of cosines. But what I want you to get from this is the side that's on this side of the equal sign will match the angle over here by the cosine. Okay? And notice there's only one place for an angle. Everything else is lowercase letters. So that's a side, that's a side, that's a side, those are sides. The only angle involved is right after the cosine. So that angle has to match the side that's on the other side of the equal sign. Okay, so a and b are both a squared plus b squared. But then there's also that minus 2ab that's multiplied by the cosine. Okay, so I just broke it down a little bit to help you kind of remember how to use the law of cosines. Maybe a little bit easier to remember. So whichever side you choose to be a goes in for the a squared and then the a right there. Whatever side you choose to be b will go in for the b squared and right there. And then again, it doesn't matter which one you plug in for a and which one you plug in for b, as long as the correct c is put right there, much like Pythagorean theorem. So let's use this formula to find a missing side. So there's our formula. First, let's talk about when to use the law of sines and when to use the law of cosines. Law of sines in the last lesson, you had to have one angle and its opposite side, and then one other piece of information. Law of cosines is a little bit different. We have to have two sides and the angle in between, so kind of like a side angle side type deal. So if we have those two sides and that angle in between, and we're looking for the third side, that's when we use law of cosines. Or it could be we have all three sides and we're looking for one of the angles. Okay, that's the second option for when to use law of cosines. So it's good to not only know the formula, know how to use the formula, but also good to know when to use the formula. So take a look at this diagram. Okay, we have our variable right here. That's one of the sides. And we have the opposite angle. So I can't use law of sines there because I don't have the angle and its opposite side. But I do have two sides and the angle where they meet. So a side, angle, side type situation. And I'm looking for the third side. So I will most definitely use law of cosines in this situation by using that very first criteria, the side, angle, side. So let's go ahead and do this. Let's take our formula and let's start plugging in everything that we know. Now, because I'm looking for this side and it's directly across from this angle, that's what's going to go in for c in the formula. So x is going to go in for the lowercase c, and that 35 is going to go in for the uppercase c. And that's the most important thing, is knowing which side and which angle go in for c. So, and the reason we know that is because they're directly across from each other. We have that angle, and we're looking for that side. So we plug them in there. X goes in for lowercase c. 35 goes in for uppercase C. And then the other two sides, the 400 and the 375, those are both going to be A and B. Now, it doesn't really matter which one's A and which one's B, so I could switch it around and make the 400 B and the 375 A, or switch it back and forth. It doesn't really matter which way you go. I'm going to go ahead and make the 400 A. So I'll plug that in there. I'll plug it in. So I've got x squared equals 400 squared. Leave a little bit of a blank, minus 2 times 400. And I'll take that 375 and plug it in for B. So now I've got x squared equals 400 squared plus 375 squared minus 2 times 400 times 375 times the cosine of 35. So that's what our formula looks like with everything all plugged in. Next thing I'm going to do, let me back up a second, okay? Let's focus on that. That's what it looks like when everything's nice and plugged in, okay? So now, normally what I would say is try to get the variable by itself. Well, the variable is pretty much by itself, okay? It's the only x in the equation, and it's all the way over here on the other side of the equal sign. What I need to focus on now is simplifying everything else on the other side of this equal sign. So if I'm trying to simplify things, I need to use my order of operations, PEMDAS. Please excuse my dear Aunt Sally. So there's nothing I can do within the parentheses, but I can do exponents. So my exponents say to square the 400 and square the 375. Next step is multiplication and division. Now, I see some multiplication here, but I want to be clear about this. When I take a look at everything that's underlined, that's all being multiplied. That's all one term right there, okay? So when I multiply, I'm going to multiply the negative 2 times the 400 times the 375, and I can do that fairly easily on a calculator and get negative 300,000. But I also need to multiply that by the cosine of 35, okay? So if you want to do that on your calculator, just all at once, negative 2 times 400 times 375 times the cosine of 35. And as always, make sure your calculator's in degrees, not radians. You'll get that number, negative 245,745.6132866. Now you may be asking yourself, do I have to write all that down, or can I just round to the nearest whole number or round to the nearest tenth? My advice, write down what you want, but keep that number in your calculator. Okay? Don't clear that out of your calculator. Some people, they'll write down the number and they write down the rounded number and then they immediately clear out their calculator. Don't do that. Okay? Keep it in your calculator. So we've done parentheses, exponents, multiplication. Well, there's no division, so multiplication and division. So then we move on to adding and subtracting. And what I need to do now is I need to add these three terms. So the 160,000, 140,625, and the negative 245, blah, 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 blah. So that's why I say keep it in your calculator, because that number's already there. All I need to do now is add the 160,000 and add up the 140,625. And there's that number without having to worry about, where do you round to, okay? It's all in your calculator. It's all very precise. And last thing to do is to get rid of that squared on the exponent. So the way we get rid of the squared is by doing the square root. So depending on how your calculator works, some calculators, you've got that number in your calculator, you can hit square root and it automatically does it. Other calculators, you have to hit like second and then square root, and then they'll say, well, what do you want to take the square root of? And most calculators that do that will have a answer button on there. And what that does is it says, if I want to take the square root of something, I want to take the square root of my last answer. So what I would do is I would do second square root and then second and find that answer button, and it'll automatically populate what's underneath the square root with that 54,000. Okay? So that way there's no need to round and worry about what place to round it to until the very end. But once you do take that square root, you should get 234.26. My rule of thumb is round at the very end of the problem to 2 places. Okay? And if there's any confusion, we can talk about this in class, how to find that answer button. Once you get used to it, it's really a lot easier than writing down everything. Okay? And worrying about, what place do I round it to at the beginning and compared to that at the end. So you'll get used to it. All right? But that's the process for finding a missing side by using law of cosines. Okay? So go ahead, take a breath. Let's relax for a second because we're about to move into how to find a missing angle. Take a sip of a tasty beverage if you like. All right. Find a missing angle. So there's two scenarios when to use law of cosines. We talked about the first one when you've got that side angle side and you're looking for that third side. Or if you have all three sides already and you're just looking for one of the angles. So let's explore that option with this example. Here I've got all three sides, 16, 8, 22, and I'm looking for angle x. So let's use the law of cosines to figure out angle x. So first off, I find the angle and the side there directly across from each other, and that's what's going to go in for C. So the 16 is going to go in for the lowercase c, and the x is going to go in for the uppercase c. So let's go ahead and plug that in. And then the 8 and the 22, those are going to go in for A and B. Doesn't matter which one's which. So I plugged in the 8 for A and the 22 for B. And don't forget the -2. That's part of that formula. Okay? So there's my formula, all put together. 16 squared equals 8 squared plus 22 squared minus 2 times 8 times 22 times the cosine of x. Okay? So that's half the battle, is identifying where things go in their proper place. So now let's go ahead and worry about how to solve this and get x all by itself. All right, so we have a lot of stuff that we can simplify, just like in the last problem. So let's start with our order of operations. There's nothing I can do within the parentheses, so we move on to exponents. Obviously, 8 squared is 64. If we back that up, 16 squared is 256. And you might need your calculator, but 22 squared is 484. So we go ahead and get those numbers. And I'm going to go ahead and leave the rest of the problem as is, because that's the only part that we can do with exponents. So after exponents, we do multiplication and division. So the multiplication I see the -2 times 8 times 22 times the cosine of x. All right, so if I multiply all that stuff, the -2 times 8 times the 22 makes -352. Now, I can't type in cosine of x because I don't know what x is yet. So I'm just going to leave cosine of x as cosine of x. Okay? So hopefully there's no question about what we've done so far. We've just done exponents and multiplying. There's no division, so we move on to addition and subtraction. And obviously I can add the 64 and the 484, so let's do that real quick. And here's a fatal mistake that a lot of people make. They say, well, I'm doing the addition and subtraction step, so I added those two and I got 548, and then I need to subtract 352, and so they get 196 times the cosine of x. Now, the reason that's wrong is because this 548 doesn't have anything on it. It's just 548. But this 352 has cosine of x multiplied to it. So that makes them not like terms. So I cannot combine the 548 minus 352 because they're not like terms. So don't do that. All right, let's back it up. And instead of taking that 548 and subtracting the 352, instead I'm going to move that 548 over to the other side with the 256. And I get -292 equals -352 times the cosine of x. Okay? So don't combine the 542 and the 342. Instead, move that 548 over to the other side. Now, it looks like we're really close to getting the cosine all by itself. So I need to divide. Well, yeah, let's clear out a little bit of space here. I was running out of room here, so I'm going to clear out the first two lines and the minus 548. Okay, so just cleared up a little bit of space there. But now I'm going to divide by negative 352 on both sides. Again, for the sole purpose of the 352s canceling out. And when I plug that in on my calculator, negative 292 divided by negative 352, I get 0.8295454 equals the cosine of x. Okay, again, don't worry about what place you're going to round to, not till the very end, but keep that number in your calculator, okay? So now I'm very close to having x by itself. I just need to get rid of the cosine. So you should remember from previous lessons, the way you get rid of a cosine is by using the inverse cosine. So I do the cosine -1 to both sides of the equation. Again, for the sole reason that the inverse cosine and the cosine cancel each other out. So I get the inverse cosine of that number that's in your calculator. And again, depending on your calculator, you might have to do like second cosine and then second answer to get that in there. Okay, again, something we can talk about when we're in class. But then once you hit that button on your calculator, I get 33.9479. But if we're talking about an angle, I always round that to the nearest whole angle. So I know x will be 34 degrees. All right. So if there's any questions, please feel free to ask in class. Let's go ahead and do a few more examples and just kind of work through how this all meshes out, okay? All right, so here we have an example. It says find AB, so I will call AB x. But let's double check. Can I use the law of cosines here? So I've got two sides and the angle where they meet. So I've got side, angle, side, and I'm looking for that third side. So yes, I'm definitely going to use the law of cosines here. So if we use that formula, you should remember that the angle and its opposite side go at the two ends of the equation. So let me write that out. So there's the part that deals with Pythagorean theorem, and then minus 2ab times the cosine of c. So that 95, that's the only angle that's going to go in for our capital letter C. And then x is going to go in for lowercase c. And I'll give you a heads up. Anytime you're finding the third side using the law of cosines, x will always go right there. There's no way for x to go in for a or b, okay? But I can plug in the 20 and the 22 for a and b. So 20 squared plus 22 squared minus 2 times 20 times 22 times the cosine of 95. Okay? So that's a big part of the battle, is just getting things plugged into the right spot. From there, we use a lot of PEMDAS to go ahead and simplify what we get. So x squared equals 20 squared is 400. 22 squared is 484. And I'll leave the rest of it for the next step. So we've done our exponents. Now let's go through into our multiplication for that whole big last term. So I'm going to do negative 2 times 20 times 22 times the cosine of 95. And I get 76.697. It's actually a positive. Okay, now I'm not going to worry about what I'm going to round to because I'm going to keep that number in my calculator. Okay? So I just did multiplying, so now I do adding and subtracting. So I will add the 400 and the 484 with what I just had in my calculator. And I get 960.697. Okay. And again, I'm not too worried about what I'm rounding to just yet because I still need to take the square root of that. So I'm going to, on my calculator, do second square root, second answer, and I get 30.995. So if I round to two places, let's see, 995, that 5 would round that up to actually 31. Now let's see if that makes sense. Okay, that side is across from the biggest angle. Would it make sense that 31 is the biggest side? Absolutely. So I think I'm in good shape for finding the length of AB, 31.00. I like it. Let's do another example where we find a missing angle. Let's change up our colors just for fun. So we're finding angle A. So that means A and 10 go in at the two ends of our equation. So that's going to be 10 squared. And then the 11 and the 17, I'll go in for A and B. It doesn't matter which one it does. So I'll do 11 squared plus 17 squared minus 2 times 11 times 17 times the cosine of A. Okay, everything's in the right spot. That 10 and the A have to be in the right spot. The other two numbers can fill in for A and B, whichever way you want to. Okay, so now that I've got everything all filled out in the right order, let's go ahead and do our exponents. So 100 equals 121 plus 17 squared. I want to say that's 289, but let's double check. Yep, 289. And leave the rest of that for the next step. Okay, so we've done exponents. Now let's move on to multiplication and division. So I will multiply the negative 2 times the 11 times the 17. So that's going to be 17 times negative 22. And I get negative 374 times the cosine of A. All right. So far it's very, very similar to finding the missing side. But here's where it gets a little bit weird. Okay, well, first off, let's go ahead and add up the 121 and the 289. So that's going to be, what, 410, I believe. Okay, so here's where it gets weird compared to finding the side. Instead of combining all this stuff, the 410 and the negative 374, I can't combine those because they're not like terms. Instead, I have to move that 410 over to the other side of the equal sign. So I'm going to subtract the 410. And I get negative 310 equals negative 374 times the cosine of A. So now in an effort to try to get A all by itself, I'm going to divide by 374, or actually negative 374. And when I do that, I will get so I end up getting 0.8288 blah, 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 blah equals the cosine of A. Again, I'm not too worried about rounding on my calculations because I'm going to keep that in my calculator. But now I need to do the inverse cosine to both sides. So that inverse cosine and that cosine cancel out, and I get A equals 34.016. So round to the nearest whole degree is 34 degrees. All right. So it gets a little weird at the end when you're trying to solve for the angle, but nothing that we can't handle. Okay. Let's go ahead and do one more example. And in this one, we're going to not only find the missing side, we're going to find everything. We're going to solve the entire triangle. All right, so you might be thinking, oh gosh, if it takes that long to do one thing, we've got to find a whole bunch of other things. This is going to be a nightmare. It actually gets better. Law of cosines is actually the longest part of this. So here we have two sides and the angle in between, so side angle side, and we're going to try to find this third side. So we know how to do that. Let's identify our angle and opposite side. So then I will have x squared, not plus, it'll be x squared equals, and again, if you're trying to find that third side, x squared will always start off your equation. So 17 squared plus 30 squared minus 2 times 17 times 30 times the cosine of 88. Okay, everything's plugged in right where it should be. Let's start with the exponents. So 17 squared is 289. 30 squared is 900. So next step, let's multiply. So I'm going to take negative 2 times 17 times 30 times the cosine of 88. And I get negative 35.5974, whatever. It's in my calculator. So moving on to the addition and subtraction step, I'm going to add all that together. So I'm going to take what's already in my calculator, and I'm going to add 289 and 900. And I get 1,153. 0.40, blah, blah, blah. It's still in my calculator, and the last thing I have to do is take the square root of that. and I get 33.96. Now, does it make sense that I'm willing to bank that 88 is the biggest angle in the triangle? Does it make sense that the 33.96 is bigger than the other two sides? I'd say so. So let me go ahead and clear that out and actually write in the 33.96. Okay? So of all the things that we need to find, we have all the sides, and we've only got one angle. So we need to find the other two angles. So the way we're going to do that, we're not going to use the law of cosines again. I mean, we could, but there's a much shorter way. Because now we have this 88 degrees, the angle, and the side opposite of it. So we have what we need to do law of sines. So I'm going to set up the sine of 88 over 33.96 equals the sine, I could do A or C. Let's do A first. Sine of A over 17. There we go. Now I can use law of sines. So 17 times the sine of 88 equals 33.96 times the sine of A. Let's divide both sides by 33.96. So sine of 88 times 17 divided by 33.96. So I get basically 0.5. $50028. So now to get A all by itself, I have to do the inverse sine. So the inverse sine of that is 30.01. If I round to the nearest whole degree, that's 30 degrees. Okay. So now I've got all three sides. I've got two of the angles. You might be thinking, oh, so I've got to do law of sines again to do the third angle? No, you can figure out the third angle pretty easy because the three angles have to add up to 180. So if I just take those and I subtract it from 180, then I should end up getting 62 degrees. And there we go. I've got all three sides. I've got all three angles. The entire triangle is solved for. All right? So a little bit of a hassle, but it can be done. If you guys have any questions, please feel free to email me or ask me in class. I'd be glad to help you guys out. And this should wrap up our chapter. So be looking forward to the chapter test. I don't think anyone looks forward to a test, but look forward into your timeline for a chapter test coming up. All right? You guys have a good one, and I'll see you real soon.